beyond my control. Sharp. So we said there are 3 forms of the quadratic function. Okay, I'm going to do them slow. Quadratic functions. Kachab. Okay, now how does the quadratic function look like? It looks like this. Sometimes it could look like that. That's what the quadratic function is, just so you guys remember. Just putting it out there. 3 forms of a quadratic function. They are: 1, standard form. The second one, turning point form. Third one, x-intercept form. X-intercept form. This is the same as saying, like, you could describe me in describe me myself in 3 different forms. You could use my name to describe me, or you could use my nickname, or you could use my surname. Let's take an example. Let's just say the president. You could use his name, Cyril. You could use his nickname, Cupcake. You could use his surname, Ramaphosa. You could use his title, Mr. President, right? So we are describing the same thing but in 3 different forms. We are able to do that. Similarly, the quadratic functions has 3 ways in which we could describe, or 3 forms in which we could put it. The first one being the standard form, then the turning point form, or the x-intercept form. I'm just going to quickly touch on each one of them and compare them quickly. The standard form says you are able to express the function as ax squared plus bx plus c. Sharp. Now, there are like 2 pieces of information you can get from the standard form. The first being the last number there. Whatever you have at the end there is your y-cut, or the y-intercept. Okay, what do I mean by that? If you get a function like so, as an example, e.g., y equals x squared plus 5x plus 6, right? This expression is in this form, standard form. Why? I've got a squared with something in front of it. That's a. That's my a. That's basically 1. Then I've got x, and I've got something in front of it. In this case, 5. That's my b. And then at the end, I've got my c. Whatever number I have at the end is my y-intercept or y-cut, which means your function will be something like this. It'll like basically cross, or it could be however it is. It'll cross the y there at 6, or however it crosses it, but it's going to cross the y at 6. Are we all happy with the meaning or the role or the significance of C under the standard form? Please show by way of a thumbs up if you're happy with that. Okay, most of you seem to be happy. Karabo, are you happy? Tabi, happy? Okay, chill. We're all happy. So now that is the first piece of information, a bit of information you are able to get from the standard form. The second bit of information, as I said, there's 2. It is the value of a, right? If a is positive, yeah, is a positive number, your graph will smile. It will be U-shaped. It will smile. It will be a smiling face. If your a is negative, your graph will frown, will be sad. Okay, so that's another bit of information you get from the standard form. For example, y equals 3x squared plus x plus 1 would mean that your graph will be, will a graph be U-shaped or N-shaped? Let's talk. Yeah, so I've got this example there. This is a quadratic function, and it is in its standard form, as it is in the form ax squared plus b squared plus c. So my question is your graph gonna smile or frown? Yes, it'll be smiling. Yes. Why? Because the value of a there is positive. A just means the number in front of x squared. B just means the number in front of x. Then C just means the number that's chilling alone there. So since our a is positive, our graph will then smile. If our A was negative, when we have to draw a graph, it will be frowning like that. All good, all on the same page, right? Proper stuff. Remember, what are we doing? We are looking at the three different forms of the quadratic function. As mentioned, we've got the standard form, the turning point form, and the x-intercept form. So far we've covered the standard form, and then we said that we get 2 bits of information from the standard form. That is the y-cut or the y-intercept and the shape of the function. So that's what we get at outset. Now let us quickly touch on the turning point form, the second form. Remember, I'm just breezing through this for the next 2-3 minutes, and then after that I'm gonna do these different forms one by one so that you guys can fully understand what's going on. So the turning point form comes like this. Use purple. Y equals, please don't write anything down. As I said, this thing is recorded, ne? Please don't do that to me. Sharp. The second form of or the second way in which a specific quadratic function can be represented is the turning point form. All right. So what does it give us? It's in the name. It gives us the coordinates of the turning point. What do I mean by that? Your graph will come, your expression will come in this way, and then you will then be able to deduce the turning point from this. The coordinates of the turning point will be P and Q. That is, whatever you have inside here, ne, you're gonna take the opposite sign of it. It will be an x coordinate of the turning point. I repeat, whatever you have inside the bracket there, you will take the opposite sign of it. So if it's minus p, the x coordinate of the turning point will be positive p. If this came as plus, the x coordinate of the turning point will be minus p. So it's always the opposite of what you have in terms of signs. And then for the y coordinate, you just follow whatever you give it. So if it is plus 2, then this will be plus 2. If it's minus 2, this will be minus 2. That is the y coordinate. Remember what a turning point is? The turning point is this. If it comes like this, will be that. The coordinates of those particular points. Are all happy with like what we can deduce from the turning point form? It's in the name. Thumbs up. Delicious, yeah? Sharp. So an example would be y equals 2x minus 1 squared plus 3. Can you guys tell me what are the coordinates of the turning point of this specific function? Just shout out the answer. The coordinates of the turning point. Yes, plus 1 and 3. Proper stuff. You guys are on fire. Someone needs to put you out. It's 1 and 3. It's always the opposite sign of what you have there. And this one, you just follow the sign. Let's try another example. What is the turning point or the coordinates of the turning point of this function? Coordinates of the turning point? Yeah, someone says -1, -3. The next person says proper stuff. Are we all happy? Mpo, are you happy? Shezi? Tiamo, we all good, yeah? So it's -1 and -3. Takes the opposite sign, follows the sign, eh? So never get it twisted. So that is the bit of information we get at outset, at first glance. But just looking at the expression, you're able to give the coordinates of the turning point. The second bit of information that you could deduce from the turning point form is this. Same as that day. Your A gives you the shape. So if A is positive, your graph smiles. If A is negative, your graph will frown. Are we all good? Proper stuff. Sharp. Remember that we're still going to look at each one just now, each of the 3 forms in detail. So this is just a quick summary just to give you like a holistic view of what we're going to be doing. So the third form is what we call the x-intercept form. It's in the name as well. How does it come? It comes like so. Y equals a, then x minus x1, then x minus x2. Now, do you guys know like what x-intercepts are? Like if a graph goes like this, right? It's an example. Goes like this, and there we have a 1 there, we've got a 3 there. So 1 and 3, this is basically x1. This is basically the first x equal to 0, x equal to 3. So 1 and 3 are the x-intercepts of this function, the points at which our function cross the x-axis. An x-intercept is a point or points where a graph crosses the x-axis. So this is 1. Why did I put a 0? So in this specific example, that's 1 and 3, right? So we all understand what an x-intercept is, right? So now from this x-intercept form, right? The x-intercepts of this function will then be, the first one will be the first x-intercept will be, or rather x-intercepts will be x1 and x2. You take these, whatever you have there. Now, note that we're taking opposite signs. So it's minus x1. My first one is positive x1, minus x2, positive x2. So you always take the opposite sign, for both to write down the x-intercepts. An example would be something like this, e.g. E.g. Y equals, let's just say 2, x minus 1, x minus 3. Now, if they ask you, they give you something like this in the exam without having drawn the graph, and they ask you what are the x-intercepts of this function, you don't have to even bother yourself doing calculations. You see that this is an x-intercept form. It's in that form. So just write them down. That's the opposite sign of that. The first one, you could say x1 is 1, and the second one is x2 is 3. You take the opposite signs of what you have there. Another example would be y equals 2 x minus 1 x plus 3. If they ask you what are the x-intercepts, it will be x1 is equal to 1, and then x2, the second x, it's minus 3. So your graph will look like this, just a sketch. It will look something like, so it will be minus 3, 1 there. Do you guys follow? Any questions?